Oceanography News.
The stars above me are closing in, so water roll me home. Day will come, but night is long. The siren song still calls me young. The fading candle is growing dim, so water pull me in.
Knowledge of the oceans is more than a matter of curiosity. Our very survival may hinge upon it.
Welcome to Ocean News episode 20, and this week we're starting off with a drone boat drag race. When it comes to speed and maneuverability, this company is claiming its Typhoon, with a top speed of 50 knots and a range of 800 nautical miles, is setting the new standard for drones. Next bit of ocean news is EU's Copernicus Sentinel 6B oceanography satellite was successfully launched. These are extremely important satellites for measuring the world's oceans.
We're measuring the height of the ocean from space. Shipping, national security, fisheries, all of these depend on this information. The way the Sentinel 6B measures is it sends a radar signal down to the surface of the ocean and measures how long it takes that signal to get back to the satellite. And from that, we can really get a very accurate measurement of how sea levels are changing locally and on a global scale, down to about a 1-inch accuracy.
We've been tracking changes to sea level for more than 30 years now. Sentinel 6B carries on this legacy of measuring sea level in a very consistent and very accurate manner.
The ocean is very dynamic, it changes all the time. Having a measurement really is important towards understanding what's happening with the ocean, both in real time, but also in terms of forecasting. Having access to data within hours on where a hurricane is headed, how intense it is crucial, especially in those extreme events.
Better predictions allow people to get out of the way. We're in the business of trying to avoid emergencies, not just respond to them after the fact.
The Copernicus Sentinel 6B Earth observation satellite has successfully been launched from the U.S. Vandenberg Space Force Base, VSFB, California, by a Falcon 9 vehicle operated by SpaceX. Thales Alenia Space, the joint venture between Thales and Leonardo, supplied the Poseidon 4 radar altimeter and the S-band transponders for the Sentinel 6B, built by Airbus Defence and Space as prime contractor for the European Space Agency, ESA. The Sentinel-6 mission is a part of Copernicus, the Earth observation component of the European Union space program, and the result of a unique collaboration between the European Commission, ESA, UNITSTAT, NASA, and NOAA, with support from the French space agency CNES. For 1 year, Sentinel-6B will orbit in tandem with Sentinel-6, Michael Freilich, launched in November 2020 to calibrate the two missions before taking over from its predecessor. The gold standard radar altimetry mission will ensure continuity of sea level data through to at least 2030. With 10% of the world's population living less than 10 meters above sea level in coastal communities, sea level rise is one of the main concerns relating to Earth's changing climate. The global level of oceans is currently rising an average of 3.3 millimeters a year, a rise that has accelerated in recent years, potentially spelling dramatic consequences for these populations. Like its twin Sentinel-6, Michael Freilich, Sentinel-6B is carrying the Poseidon 4 altimeter developed by Thales Alenia Space. This highly precise radar altimetry technology measures open topography every 10 days with sub-centimeter accuracy. Ocean topography is a critical indicator surveying climate change as well as ocean dynamics, currents, wave height, and surface wind speed. Precise and continuous monitoring of sea level is crucial to acquire reliable data informing effective climate policies for governments and institutions, and to protect the millions of people under threat from sea level rise. Such data is also invaluable for emergency responders in the event of a disaster, and for departments in charge of urban planning, building safety, and levee management. I'm delighted to see the successful launch of the Sentinel 6B satellite, which will ensure continuity of high precision ocean topography data vital for surveying climate change and protecting coastal communities, said Hervé Derry, President and CEO of Thales Alenia Space. Thales Alenia Space's teams, who have been instrumental in the successful satellite altimetry missions from the outset, can be proud of the latest achievement reflecting the excellent international collaboration in space oceanography. With a launch mass of around 1.2 metric tons, Sentinel 6B will operate in low Earth orbit at an altitude of 1,336 kilometers and has a design life of 7 years. Thales Alenia Space is a major contributor to 11 of the Copernicus program's 12 missions. Sentinel-1 monitors land surfaces and seas in all weather conditions, day and night. Thanks to its radar capabilities, Sentinel-2 and 3 acquire high-resolution optical imagery over land and coastal waters. Sentinel-4 and 5 are dedicated to meteorology and climatology missions. Sentinel-6 surveys the planet's oceans, as well as being prime contractor for the Sentinel-1 and 3 satellite families. Thales Alenia Space also supplied the Sentinel-2 image ground segment and helped build the imaging spectrometer on the Sentinel SP and Poseidon 4 radar altimeter. On Sentinel-6 in 2020, Thales Alenia Space was awarded 5 contracts for the 6 Copernicus expansion missions, a prime contractor for the CMIR, Rose-L, and Chime satellites, and a supplier of the Crystal and CO2M mission payloads. These new satellites will measure human-induced atmospheric carbon dioxide, survey sea ice and snow cover, support new optimized services for sustainable farming and biodiversity, observe sea surface temperature and salinity, as well as sea ice density, and strengthen land monitoring and emergency management services. The country of Iceland is taking the collapse of the AMOC very seriously. Iceland has deemed possible Atlantic current collapse a national security risk. Quote, is a direct threat to our national resilience and security, unquote, Iceland Climate Minister Johan Paul Johansson said by email. This is the first time a specific climate-related phenomenon has been formally brought before the National Security Council as a potential existential threat. Elevation of the issue means Iceland's ministries will be on alert and coordinating a response, Johansson said. The government is assessing what further research and policies are needed, with work underway in a disaster preparedness policy. Risks being evaluated span a range of areas, from energy and food security to infrastructure and international transportation. The ripple effects. An Atlantic current collapse could have consequences far beyond northern Europe. It could potentially destabilize long-time rainfall patterns relied upon by subsistence farmers across Africa, India, and South America, according to scientists. It could also contribute to faster warming in Antarctica, where sea ice surrounding the most southernmost continent as well as ice sheets atop it are already under threat from climate change. This has spawned articles recently such as this one, A New Ice Age, the Atlantic Ocean is on brink of collapse, from Surfer. Scientists warned of potential environmental catastrophic as a critical Atlantic Ocean current is under threat from climate change. Scientists are sounding the alarm as a critical Atlantic Ocean current is under existential threat. The result, if things take a turn for the worse, a new ice age. Sounds extreme, hysterical, but science shows the drastic change amidst the Atlantic Meridional Overturning Circulation, also known as AMOC, an ocean current which transfers warm water from the tropics all the way up to the Arctic, and that flow of more temperate water into the frigid depth of the north is a key asset in keeping Europe's winters mild. Here's the problem. The warmer water is increasing as a result of climate change, thus accelerating the thaw of Arctic ice, and if this continues, scientists warn that the critical ocean current AMOC could collapse and potentially trigger a new ice age. How this will impact swell and surfing is unclear. However, it most certainly will in some way, either good or bad. But the real threat is environmental catastrophe. The last ice age, the one we all learn about in school, ended about 12,000 years ago. It just so happened that, according to the scientists, the AMOC collapsed right before that catastrophic global freeze took hold. During that period, known as the Pleistocene Age, was marked by massive ice sheets covering continents, woolly mammoths roaming the Earth, and mass extinctions from a variety of species. Well, in good news, in opposition to the previous article, we have rapid melt from Antarctica could help preserve crucial ocean current. Greenland's melt is expected to slow the Atlantic meridional overturning circulation, but research suggests a collapse of the West Antarctic ice sheet could in some cases prevent it from shutting down. While the melting of the Greenland ice sheet is expected to slow or even collapse the Atlantic current that keeps Europe warm, meltwater from West Antarctica could preserve this vital current, but it won't be enough to prevent major changes in the climate. The Atlantic meridional overturning circulation would still decline by 60%, and its full recovery would take 3,000 years. I would tend to say, don't be so quick to say that the AMOC is going to collapse, says Sascha Sinet at Utrecht University in the Netherlands. But the things I show here do not change much what will happen for the next century. Probably you will not be alive to tell if the AMOC was stabilized or not by West Antarctica. AMOC is a system of currents that brings warm surface water from the tropics towards northern Europe, where it cools and sinks before flowing south to Antarctica. The current carries 1.2 petawatts of heat, equivalent to the energy generated by 1 million power plants. That keeps Europe much warmer than Labrador or Siberia at the same latitude. But light, fresh meltwater from Greenland's ice is expected to hinder the sinking of the salty, dense AMOC water, slowing down the current. If the AMOC collapsed, winter cold snaps could reach almost minus 50 degrees Celsius, which is minus 58 degrees Fahrenheit, in northern Europe. This week, Iceland declared AMOC shutdown an existential security threat. Sea levels would also be higher along the U.S. East Coast, and Africa could suffer more severe droughts. Recent research concluded that even if we reach net zero by 2075, and then start removing CO2 from the atmosphere, the risk of eventual AMOC collapse could still be 25%. One study predicted a shutdown within decades, while another said Antarctic winds would keep the AMOC going in a weakened state. Meanwhile, the melting of the West Antarctic ice sheet has been accelerating in recent decades, and some research suggests that it is likely to collapse completely. But the effect this will have on the AMOC is unclear. According to simulations by Sinet and his colleagues, the timing of the melting is key. If a centuries-long pause of Antarctic meltwater arrives at the same time as massive melt from Greenland, it will only speed up the AMOC shutdown. If the Antarctic water arrives about 1,000 years before the peak of Greenland's melting, however, the AMOC would weaken for several hundred years, but then recover over the next 3,000 years. While the AMOC eventually recovered in all scenarios, this early Antarctic melt prevented its total collapse and sped up its revival. This may be because as light, fresh meltwater pools around Greenland, the sinking of dense, salty AMOC water shifts southward, and the current later regains strength as meltwater tapers off from Antarctica. Although it's unlikely that West Antarctica would melt so early while Greenland would melt so late, these findings reveal a greater connection between the AMOC and Antarctic melt, says Louise Syme at British Antarctic Survey. I don't think we knew until this study that there was this possibility that changes in Antarctica could potentially change so much the impacts of Greenland ice sheet on the AMOC, she says. However, the connection should now be investigated with more complex models, as the study didn't include possible feedback effects like changing wind patterns, which could expand Antarctic sea ice, she adds. Even if drastic West Antarctic melt prevented AMOC collapse, it would still cause as much as 3 meters of sea level rise, flooding coastal cities. Unfortunately, it is not a consolation if one catastrophe might perhaps reduce the risk of another catastrophe, says Steven Raumstorff at the University of Potsdam, Germany. Fortunately, D2 has the perfect technology to measure this change in the ocean water from salty to freshwater if melting is taking place. And that is our line of CTD products, such as this titanium version that goes to 11,500 meters and provides the most accurate salinity measurement that you can find in the world. We even have this brand new model that's designed to fit into existing AUV wetted sensor bays. And this provides extremely accurate, world leading precision for conductivity, which will allow researchers to determine if the meltwater is mixing into the current or not. This is the exact technology they would need to do the studies that they want to do to measure this. Make sure to visit d-2.com to check out our full line of oceanographic solutions and products. And remember, saltier seas make for better lightning. Also make sure to hit the news tab and bookmark our D-2 news webpage so that you never miss an important ocean news update.
Knowledge of the oceans is more than a matter of curiosity. Our very survival may hinge upon it.